In the lesson 6.6 example, mean texts, we're going to look at probabilities involving X bar. Suppose that the mean number of texts sent during a typical day by this population of students at a large high school follows a right-skewed distribution with a mean of 45 text messages and standard deviation of 35 text messages. We want to know how likely it is that a random sample of 100 students will produce an average of at least 50 texts per day. So what we need to do is we need to first define what we're going to use. We're going to say that X bar is the sample mean number of texts sent by the 100 selected students. And we want to know what the probability is that that number, X bar, is at least 50. We know that the mean of X bar, if we had selected 100 students over and over and over again, that the average of all those sample means would have been 45 texts. And the standard deviation of those sample means is calculated this way by doing the standard deviation divided by the square root of the sample size, which ends up being 3.5 texts. So what we can do is we can use this information to try and find the probability that X bar exceeds 50. But before we do that, we need to identify that the shape of the distribution of X bar is approximately normal, if we're going to use normal calculations to find that probability. Since n equals 100, the central limit theorem is going to guarantee an approximately normal sampling distribution, since 100 is greater than 30. So now we can use the normal distribution using 45 texts as the mean and 3.5 texts as the standard deviation of X bar. So we'll draw that out. The sample mean number of texts, X bar, with an average of 45 and standard deviations of 3.5 marked off on either side. We want to know what the probability is that X bar, the sample mean number of texts, will exceed 50. 50 is right here, so we need to now find its z-score. The z-score corresponding to 50 is 50 minus 45 over 3.5, or 1.43. Using table A, we can find the probability that z is greater than 1.43 as 0.0764. Just a quick note, you could also have used a calculator's normal CDF function or the applet that comes with this textbook to say the low value of the range that we want is 50. The high value is anything really, really large to the right. I wrote 10,000. The mean is 45 and the standard deviation is 3.5. That probability will give you a number very, very close to what table A ended up giving us. If you'd like to try a problem like this in your textbook, you can try exercise 5 in this section.